The night is a heavy velvet curtain drawn softly across the window of the world. It is a time for stillness, a time when the frantic motion of the day settles into a quiet rhythm, like dust motes drifting slowly in a shaft of moonlight. Take a moment before we begin to find your own stillness. Let your shoulders drop away from your ears. Unclench your jaw. Let the muscles of your face soften, smoothing out the worries of the waking hours. Feel the weight of your body sinking into the mattress, supported, held, safe. Tonight, we are going to take a journey. We are not traveling outward to the distant stars, though we will find them along the way. We are traveling inward. We are going down, past the skin of the world, past the cells of life, past the molecules that make up the air you breathe. We are drifting down into the basement of reality, into the quiet, shimmering world of the quantum. Chapter 1: The Grain of the Universe. It is a strange place, a place where the rules of the everyday world dissolve like mist in the morning sun. But do not worry. You do not need to solve equations here. You do not need to memorize facts. You only need to drift, to watch, to listen to the hum of the universe at its most fundamental level. Imagine, if you will, a stream of water. Visualize it pouring from a pitcher, crystal clear, catching the light. It looks smooth, doesn't it? A single, continuous sheet of liquid, bending and flowing without a break. For centuries, this is how we thought the universe was built: smooth, continuous, unbroken. We believed that energy flowed like that water, a seamless river. We believed that if you zoomed in closer and closer still, you would just see more smoothness. We thought nature was painted with a wide brush in long, sweeping strokes. But in the year 1900, a man named Max Planck looked closer. He was looking at something very simple: heat. Imagine a blacksmith's forge. Picture a piece of iron thrust into the heart of the fire. At first, it is dark. Then, as it warms, it glows a dull, deep red, then bright orange, then a blinding yellow, and finally, if it gets hot enough, a piercing blue-white. Planck tried to explain this beautiful gradient of color using the old rules, the rules of the smooth river. But the math failed him. The equations said that the iron should glow with an infinite brightness, a catastrophe of energy that would consume everything. But the iron didn't destroy the world. It just glowed, calm and steady. So, Planck made a guess that would shatter the mirror of classical physics forever. He imagined that energy did not flow like a smooth stream. Instead, he imagined it falling like rain. Visualize that stream of water again, but now look closer. So close that the smooth sheet breaks apart into billions of tiny, individual droplets. Planck realized that energy comes in packets, tiny, indivisible chunks. He called them quanta. This was the birth of the grainy universe. It means that reality is not a slope. It is a staircase. You cannot stand between the steps. You must be on one step or the next. The universe counts. It deals in whole numbers. It pays in coins, not in fluid value. Deep down, beneath the smoothness of your skin, beneath the solid wood of your floor, The universe is pixelated. There is a smallest possible thing, a smallest possible action. Planck discovered a number, a tiny, impossibly small number, that describes the size of these pixels. We call it Planck's constant. It is the grain size of existence. It is the resolution of reality. If this number were large, if the grain was the size of a marble or an apple, the world would be a chaotic, flickering nightmare. You would see the world jump and stutter like a broken film reel. But the grain is small, so small that 10 billion trillion of them could fit inside a single atom. And because it is so small, the world appears smooth to us. The staircase looks like a ramp. The rain looks like a river. But tonight, as you drift toward sleep, remember the truth. The smoothness is an illusion. We are floating in a sea of tiny, glittering droplets of energy. Let yourself sink deeper into this idea. The air in your room feels still, but it is not empty. It is filled with these tiny packets of energy, flickering, vibrating, dancing. The heat of your body is a gentle radiation of these quanta, leaving you like slow breaths, warming the sheets. This discovery changed everything. It was the first key to a door that had been locked since the dawn of time. And when scientists opened that door, they did not find a dark, empty room. They found a wonderland. As we step through that door together, the first thing we notice is the light. Light has always been a mystery. For thousands of years, we argued over it. Isaac Newton, the father of gravity, imagined light as a stream of tiny bullets, corpuscles, flying through space. He saw light as particles, solid, distinct. But others looked at how light bends around a corner, or how it ripples like a pond when you toss in a stone, and they said, no, light is a wave. And for a long time, the wave theory won. We could prove it. If you shine a light through two narrow slits cut into a screen, the light spreads out on the other side. The waves overlap. Where two crests meet, they get brighter. Where a crest meets a trough, they cancel out into darkness. It creates a pattern of stripes, a zebra crossing of light and shadow. Only waves do that. Bullets don't ripple. So we settled it. Light was a wave. The universe was an ocean of electromagnetic vibrations. But then came Albert Einstein. He looked back at Planck's discovery that energy comes in packets, and he asked a simple, dangerous question. What if light itself is grainy? Imagine standing on a beach on a sunny day. You feel the warmth of the sun on your skin. It feels like a continuous blanket of heat. But Einstein said that light arrives not as a continuous wave, but as a rain of particles. He called them photons. Each photon is a tiny packet of light, a droplet of sun. When you see a red light, you're being touched by photons with lower energy, lazy and slow. When you see a blue light, you are being struck by energetic photons, vibrating quickly. This was proven by the photoelectric effect. Imagine a sheet of smooth, cold metal. If you shine a light on it, you can knock electrons loose from the surface, like pebbles being kicked off a cliff. If light were just a wave, a very bright, intense red light should be like a massive tidal wave. It should have enough power to wash the electrons away. But it doesn't. You can shine the brightest red spotlight in the world on that metal, and the electrons won't budge. But turn on a dim, faint blue light, barely a whisper of illumination, and the electrons fly off instantly. Why? Because the red photons, no matter how many of them there are too weak individually. They are like ping pong balls thrown at a boulder, but the blue photons are like heavy rocks. Even one of them carries enough punch to knock an electron free. So, light is a particle. The debate was over. Or was it? This is where the dream begins to bend. This is where the logic of the day gives way to the magic of the night. Because nature refused to choose. When we ask light, "Are you a wave?" it behaves like a wave. It ripples, it bends, it interferes. When we ask light, "Are you a particle?" it behaves like a particle. It strikes, it counts, it punches. It is both, and it is neither. It is a shapeshifter, a phantom. Imagine a shape suspended in the air. If you shine a light on it from the front, it casts a shadow of a circle on the wall. If you shine a light from the side, it casts a shadow of a square. Is the object a circle, or is it a square? It is a cylinder. It is something more complex, something richer, which can only be understood by looking at its shadows. Light is like that. We cannot see its true face. We can only see the shadows it casts in our experiments. Sometimes it casts the shadow of a wave, sometimes the shadow of a particle. But its true nature, its quantum nature, is something beyond our language. Drift with this image. You are floating in deep space. A single photon, a solitary spark of creation, is traveling toward you from a distant star. It has traveled for 1 billion years. For all that time, as it crossed the void, it was a wave. It was spread out. It wasn't in one place, it was in many places, expanding like a ripple on a dark pond, exploring every path through the cosmos. But the moment it hits your retina, the moment you see the star, that wave collapses. Instantly, it shrinks from being light years wide down to a single microscopic point. It becomes a particle. It delivers its tiny kiss of energy to your eye, and your brain says, "Star." For 1 billion years, it was a ghost. For one final moment, it became real. This is the dual nature of reality. Everything you touch, everything you see, has this double life. The phone in your hand, the blanket over your legs, even the atoms of your own body. They are all shimmering between being solid things and being waves of possibility. You are not just a solid object lying in a bed. You are a symphony of waves, vibrating, resonating, interacting with the fields of the universe. And this brings us to the edge of the atom. For a long time, we thought of atoms like miniature solar systems. We learned this in school, didn't we? A hard, dense nucleus in the center, like a sun, and tiny electrons whizzing around it like planets in neat circular orbits. It is a comforting image, orderly, predictable, clockwork. But the quantum world is not a clock. If you could shrink down, smaller than a cell, smaller than a strand of DNA, down to the level of an atom, you would not see little planets orbiting a sun. You would see a cloud. The electron is not a ball. It is a mood. It is a mist. It is a vibration. Because of its wave nature, the electron is not in one place. It is smeared out around the nucleus. It surrounds the center like a fog. It is everywhere in its orbit at once. If you try to touch it, if you try to measure it, it will suddenly snap into a single position. "Here I am," it seems to say. But the moment you look away, it dissolves back into the cloud. It returns to the wave. It creates a shell of probability, a protective haze that gives the atom its size. Think about this. The nucleus of an atom is tiny. If the atom were the size of a football stadium, the nucleus would be a marble on the center line. The electrons would be tiny gnats buzzing in the highest seats of the stands. Everything in between, the field, the rows of seats, the air, is empty space. You are made of atoms, which means you are made almost entirely of empty space. So why do you feel solid? Why doesn't your hand pass through the table? Why doesn't the bed collapse beneath you? It is because of that electron cloud, that ghostly quantum fog. When your hand touches the table, the clouds of your electrons push against the clouds of the table's electrons. They repel each other, not because they are touching, but because the waves are interacting. You have never truly touched anything in your life. You are floating, always, on a cushion of quantum forces, hovering nanometers away from everything you encounter. You are levitating. The solidity of the world is a mirage created by the rapid motion of these waves. Like a fan spinning so fast it looks like a solid disk. If the fan stopped, you could put your hand through it. But the quantum fan never stops. It spins forever. So rest now on your cushion of fields. Feel the support of the bed, knowing that it is a dialogue between the atoms of the mattress and the atoms of your body. A silent agreement to hold you up. A promise kept by the laws of physics. The universe is grainy, yes, it is built of steps and packets. But out of those jagged pieces, it weaves a blanket of incredible smoothness. It takes the chaos of the quantum and spins it into the calm of the classical. We have only just stepped across the threshold. We have seen that light is a dual spirit and that matter is a misty cloud. But there are deeper mysteries waiting in the dark. Questions of how a thing can be in two places at once. Questions of how two hearts can be connected across the galaxy. Questions of uncertainty and the power of merely looking. The library of the universe is vast, and the lights are dim. We have plenty of time to explore the aisles. But for now, let the concept of the grainy, pixelated universe fade. Let the waves of probability wash over you. You are safe in the uncertainty. You are a wave, resting on a wave, drifting in the great, dark ocean of the night. Chapter 2. The Library of Possibilities. We are drifting deeper now. Behind us lies the familiar world of solid things, the tables, the chairs, the steady ground beneath our feet. We have left the shore of the certainty we know and pushed off into the deeper waters of the quantum ocean. The air here is different. It is thick with potential. In the previous chapter, we saw that matter is not a collection of hard marbles, but a haze of clouds. We learned that the universe is pixelated, grainy, and shimmering with waves. But tonight, the mystery deepens. We are going to explore a concept that defies every instinct you have ever had. It is the idea that a thing can be two different things at the exact same time. It is the idea that the universe does not choose a path until it absolutely has to. This is the realm of superposition. To understand this, let us return to a simple, quiet room in your mind. Imagine a wooden table. The grain of the wood is smooth, polished by time. In the center of the table, there is a coin. It is an old coin, heavy and bronze. Reach out in your mind and pick it up. Feel the cool metal against your thumb. It is solid, it is real. Now, give it a spin. Flick it with your finger and watch it dance across the wood. Round and round it goes, humming a low, metallic song. Look at the spinning coin. Is it heads or is it tails? While it is spinning, it is a blur. It is a sphere of motion. In our everyday world, we say, it is either heads or tails. I just don't know which one yet. We believe the coin has a secret. We believe that if we had a high-speed camera, we could freeze time and see exactly which face is up at any given microsecond. But in the quantum world, the coin is doing something magical. While it is spinning in that quantum state, it is not hiding a secret. It is not either heads or tails. It is fully, genuinely both. It is a ghost occupying two states at once. It is a mixture, a blend, a superposition of all its possibilities. The head's reality and the tail's reality are overlapping, singing in harmony like two notes in a chord. This is how the particles of your universe behave when you are not watching them. An electron does not spin clockwise or counterclockwise. It spins both ways. An atom does not sit on the left side of a box or the right. It sits in both corners simultaneously, filling the space with its potential. It is a beautiful, if unsettling, thought. It means that until a choice is made, the universe is limitless. It keeps its options open. It refuses to be pinned down. There is a famous story about this, a parable of modern physics told by a man named Erwin Schrödinger in 1935. It is a story about a cat. Now, do not worry, this is not a sad story. It is a story about a box that contains a mystery. Imagine a steel box. The walls are thick and soundproof. There are no windows, no way to peek inside. Schrödinger asked us to imagine placing a cat inside this box, along with a tiny, fragile device, a device controlled by a single atom. If the atom decays, a random quantum event, a mechanism trips and the cat falls asleep forever. If the atom does not decay, the cat remains awake and happy. The box is sealed. Time passes. Now, stand outside the box. What is the state of the cat? Common sense tells us the cat is either awake or it is not, one or the other. It is a binary world. But quantum mechanics tells us something stranger. It says that because the atom is in a superposition, because the atom is both decayed and not decayed at the same time, the cat, which is linked to the atom, shares its fate. Until you open the lid, the cat is not alive, it is not dead, it is suspended, it is a blur, it is a wave of possibility involving both a living cat and a dead one, coexisting in the dark. The universe has not decided. This thought experiment was meant to show how absurd the quantum rules seem when we apply them to living, breathing things. But the math insists it is true. Inside the unobserved dark, reality is a cloud of maybe. Only when you step forward, only when you lift the lid and look inside, does the spell break. This is called the collapse. The wave function, that mathematical description of all the possibilities, snaps shut. The blur resolves into sharpness. The coin stops spinning and lands flat. The cat is revealed as one thing or the other. This suggests something profound about you, about the observer. You are not just watching the universe, you are sculpting it. By looking, by measuring, by interacting, you are forcing the cosmos to make up its mind. You are the artist who turns the chaotic clay of potential into the statue of reality. Without you, the story has no ending. Let's drift away from the box now. Leave the cat in peace. Let's float down into the microscopic world to see what this magic looks like in practice. Imagine you are standing at the edge of a dense, dark forest. You need to get to the other side. There are two paths winding through the trees. One goes left, around a grove of ancient oaks. The other goes right, past a murmuring brook. You are a traveler. You are a solid thing. You must choose, left or right. But if you were an electron, you would not choose. You would become a mist. You would drift forward, and your ghostly form would split. You would flow down the left path and the right path at the same time. You would brush against the oak trees and ripple the water of the brook simultaneously. You would explore the entire forest at once. And when the paths merged again on the other side, the you that went left and the you that went right would meet. They would overlap. They would interfere with each other. Like ripples from two stones thrown into a pond, the waves of your journey would cross. Where the crests meet, they would rise higher. Where a crest meets a trough, they would vanish. This is how nature finds its way. It does not walk a straight line. It explores every possible history, every possible route, all in the same breath. This phenomenon is happening right now, outside your window. Think of a green leaf on a tree. It is soaking up the sunlight, turning it into energy. Inside that leaf, there is a tiny packet of energy trying to find its way to the reaction center, the factory where food is made. It needs to get there fast, before the energy fades. The path is crowded and complex, a maze of molecules. If the energy had to bump around blindly like a ball in a pinball machine, it would get lost. The plant would die. But it doesn't. Recent discoveries suggest that the energy moves like a quantum wave. It enters a state of superposition. It takes all the paths through the maze at once. It flows like water filling a mold, instantly finding the most efficient route, the path of least resistance. This phenomenon is happening right now, outside your window. Think of a green leaf on a tree. It is soaking up the sunlight, turning it into energy. Inside that leaf, there is a tiny packet of energy trying to find its way to the reaction center, the factory where food is made. It needs to get there fast, before the energy fades. The path is crowded and complex, a maze of molecules. If the energy had to bump around blindly like a ball in a pinball machine, it would get lost. The plant would die. But it doesn't. Recent discoveries suggest that the energy moves like a quantum wave. It enters a state of superposition. It takes all the paths through the maze at once. It flows like water, filling a mold, instantly finding the most efficient route, the path of least resistance. Every plant you see, every blade of grass, is quietly performing a quantum miracle. They are harnessing the power of being in two places at once to capture the sun. Life itself is built on this ghostly ability to explore the library of possibilities without ever opening a single door. This power, the power of superposition, is what scientists are now trying to harness in our machines. We call them quantum computers. It sounds cold, technical, but think of them as multiverse explorers. An ordinary computer thinks in switches, on or off, yes or no, 1 or 0, 1 or 0. It reads a book one word at a time, page by page. It is fast, but it is linear. A quantum computer thinks in qubits. A qubit is like that spinning coin. It is 0 and 1 together. It is a switch that is both on and off. If you link enough of these qubits together, you create a machine that doesn't just read the book one page at a time. It reads the entire library in a single glance. It can hold a million different answers in its mind simultaneously, floating in a vast, cold superposition. And then, with a delicate pulse of energy, we ask it a question. The waves of all those answers interfere. The wrong answers cancel each other out, fading into silence. The right answer amplifies, rising like a rogue wave from the ocean. It is a new way of thinking, a way of thinking that mimics the universe itself. But there is a fragility to this magic. Superposition is like a soap bubble. It is beautiful, iridescent, reflecting the entire world on its surface, but it is incredibly delicate. It requires silence, it requires cold, it requires isolation. If a stray molecule of air hits the bubble, if a warm photon of light touches it, the bubble pops, the superposition collapses, the magic vanishes, and the system becomes ordinary again. The coin falls, the cat wakes up. This is why we don't see ghosts in our daily lives. You and I are too big, we are too warm, we are too noisy. We are constantly bumping into the air, into the ground, into light. We are constantly being measured by the environment around us. The universe is always looking at us, always touching us, forcing us to be just here and nowhere else. We are living in the collapsed wreckage of the quantum world. The solid furniture, the walls of your room, the beating of your heart. These are the leftovers. These are the choices the universe made. But underneath it all, in the quiet gaps between the atoms, the dream still lives. Deep down, the particles that make you are still trying to spin both ways. They are still trying to be everywhere. So, as you lie here in the dark, imagine that you can reclaim a little of that quantum freedom. The day is done. The choices of the last 24 hours have been made. They are solid. They are history. But tomorrow? Tomorrow is a superposition. Now, imagine you try the opposite. You want to capture the speed. You want to see the motion. So you slow the shutter speed down. You leave the lens open for a long, deep breath. Click, clack. Now look at the photo. You see a beautiful blur, a streak of color rushing through the trees. You can see the speed, you can feel the momentum in the smear of the image. But look closely. Where is the runner? You cannot say. They are a streak. They are not at this tree or that tree. They are a smear across the entire path. You have captured the motion, but you have lost the position. This is the trade-off. This is the bargain we make with nature. In 1927, a German physicist named Werner Heisenberg realized that the universe works exactly like that camera. He discovered that there are pairs of qualities in the universe that are linked, like two ends of a seesaw. The most famous pair is position, where you are, and momentum, where you are going. Heisenberg realized that you cannot know both of these things about a particle at the same time with perfect precision. The more you pin down the particle's location, zooming in, tightening your focus, trapping it in a corner, the wilder its momentum becomes. It begins to vibrate, it begins to shake. The more you try to hold it still, the more it struggles to move. And if you try to measure its momentum, if you try to gauge the rhythm of its movement, its position spreads out like a drop of ink in water. It becomes a cloud. This is not because our rulers are too clumsy. It is not because our eyes are too weak. It is because the particle is a wave. Think of a wave in the ocean. Ask yourself, where exactly is the wave? Is it at the crest? Is it in the trough? Is it at the start of the swell or the end? A wave is not a point. A wave is a long, undulating shape. It needs space to exist. It needs a spread to be a wave. If you try to squeeze a wave into a single, tiny point, it stops being a wave. It disappears. So, for an electron to have a wavelength, which gives it its energy, its momentum, it must be spread out. It must be fuzzy. If it were perfectly sharp, perfectly located, it would have no wavelength. It would have no energy. It would cease to be part of the quantum dance. This fuzziness is beautiful. It means that at the bottom of everything, reality is soft. The atoms in your body are not hard, grinding gears. They are soft, overlapping clouds. This leads us to one of the most comforting truths in all of physics. Have you ever wondered why atoms don't collapse? Remember the picture of the atom? The nucleus in the center, positively charged, and the electron on the outside, negatively charged. Opposites attract, we know this. The electron wants to fall into the nucleus. It is pulled by a powerful electric force, like a magnet snapping to a fridge. According to the old rules, the electron should spiral inward, crashing into the center in a flash of light. The atom should implode. The universe should shrink into a dense, dead speck. But it doesn't. The atom is vast. The atom is empty. The atom stands strong. Why? Because of uncertainty. Imagine the electron trying to fall into the nucleus. It gets closer and closer. The space it occupies gets smaller and smaller. But remember the rule. The more you pin down the position, the wilder the momentum becomes. As the electron is squeezed into the tiny space near the nucleus, its position becomes too precise. The uncertainty principle kicks in. The electron begins to panic. Its momentum skyrockets. It starts to buzz and vibrate with frantic energy. It creates a quantum pressure, a resistance. The electron refuses to be trapped in the center, because to be trapped would mean having a precise location, and nature forbids that. So the electron pushes back. It finds a balance point, hovering just far enough away to keep its freedom, but close enough to feel the attraction. That balance point is the size of the atom. That balance point is the reason you exist, the reason the floor holds you up, the reason your hand doesn't pass through the cup, the reason matter takes up space. It is all because of this frantic, claustrophobic resistance of the electron. It is the refusal of the universe to be pinned down that gives matter its bulk. You are made of puffiness. You are made of resistance to precision. It is a strange irony. The solidity of the world comes from the fact that its building blocks refuse to sit still. Let this idea settle in your mind like a soft fog. In a world that demands so much accuracy from you, deadlines, schedules, exact words, exact change, the deepest part of you is free from that pressure. Deep down, your atoms are allowed to be blurry. They are allowed to be unsure. They exist in a state of roughly here and moving roughly that way. There is a peace in this lack of focus. It is like listening to music. Think of a beautiful, low note played on a cello. To hear the pitch, to know that it is a C, you need to listen for a moment. You need to hear the vibration, the oscillation of the sound wave. You need time. If you tried to shorten that note to a tiny fraction of a second, snap, you wouldn't hear the pitch anymore. You would just hear a click, a pop. To know the music, you must accept that it takes up time. You cannot freeze the symphony and still hear the song. The universe is a song. It is a vibration, and like a song, it cannot be frozen. It must flow. It must be allowed to blur from one moment to the next. This uncertainty extends even to the empty air. We think of a vacuum as empty space, nothingness, silence. But because of the uncertainty principle, we can never say that a patch of space has zero energy, because zero is a very precise number. Zero means we know exactly what the energy is, and nature hates precision. So even in the deepest, darkest void of space, the energy is never truly zero. It fluctuates, it jitters. Tiny sparks of energy borrow themselves from the future, appear for a microsecond, and vanish again. The vacuum is seething. It is a frothing sea of virtual particles popping in and out of existence, obeying the laws of the fuzziness. Empty space is alive. It is humming. Listen to the silence of your room. It is not dead silence. It is a pregnant silence, a silence full of potential. The air around you is shimmering with these tiny, invisible loans of energy. The fabric of space-time is trembling gently, like the surface of a drum that has just been struck. So do not be afraid of the blur. When your thoughts begin to drift, when the sharp edges of the day begin to soften into the nonsense of dreams, you are not losing control. You are simply aligning with the fundamental nature of things. You are becoming more like an electron. You are spreading out. You are trading your position for momentum. You are letting go of where you are so you can drift to where you are going. Drift into the mist. The fog is safe. The fog is the foundation. In the blur, there is stability. In the uncertainty, there is room to breathe. And as we float here in this soft, indeterminate cloud, we begin to sense a connection. We realize that if particles are waves, and waves can spread out, what happens when two waves meet? What happens when two particles interact and then separate? Do they ever truly say goodbye? Or does the wave connect them forever, across the miles, across the years? We are about to discover that in the quantum world, there is no such thing as separation. We are about to explore the invisible threads that bind the universe together. Chapter 4: The Invisible Thread. We are drifting deeper into the dream of the universe. We have seen the grainy rain of energy. We have walked the forking paths of superposition. We have rested in the soft fog of uncertainty. But now we come to a place of profound comfort, a place that answers the oldest human fear, the fear of being alone. In the classical world, the world of sun and stone, distance is a real thing. If you are in this room and a friend is on the other side of the world, you are separate. To touch them, you must travel. To speak to them, you must send a signal, a sound, a radio wave, a letter. That signal must cross the miles, fighting against the wind and the time. There is a gap between you, a silence. But in the quantum world, distance is not a wall. It is not even a barrier. In the quantum world, it is possible for two things to be so deeply connected that they share the same heartbeat no matter how far apart they are. This is the mystery of entanglement. Imagine two particles, two tiny sparks of light born at the exact same moment from the exact same burst of energy. They are twins. They are not just similar, they are part of the same whole. As they fly apart, moving away from their birthplace, they begin to spin. But they do not spin randomly. They spin in a perfect, silent duet. If one spins up, the other spins down. If one spins left, the other spins right. They are balanced. They are a zero-sum equation of motion. Now, imagine we separate them. We keep one particle here in the palm of your hand. We send the other particle on a long, lonely journey. We put it on a spaceship and send it past the moon, past the rings of Saturn, out into the deep, cold void of interstellar space. It travels for 1,000,000 years until it reaches the edge of the galaxy. They are separated by an ocean of darkness so vast that light itself would take 100,000 years to cross it. Surely they have forgotten each other. Surely the link is broken. But then you look at the particle in your hand. You measure it. You force it to choose a state. Let's say you find it spinning up. At that exact instant, not a second later, not a millisecond later, but instantly, the particle on the other side of the galaxy snaps into the state of spinning down. It doesn't matter that there was no time for a signal to travel between them. It doesn't matter that the speed of light is the speed limit of the universe. The other particle knew. It felt the touch of your measurement across the void. It responded as if there was no space between them at all. Albert Einstein, the great master of space and time, found this deeply unsettling. He believed in a universe where things happened for a reason, where influence traveled locally, step by step. He looked at this quantum connection and famously called it spooky action at a distance. He thought it was a mistake. He thought there must be some hidden instruction, some secret note tucked inside the particles' pockets telling them what to do. But he was wrong. Decades of experiments, from basement labs to satellites orbiting the Earth, have proven it. The spooky action is real. The universe allows for a connection that transcends space. Think about what this truly means. It means that space, the distance that seems so real to us, the miles that separate us from the ones we love, might be an illusion. Or at least it is not the whole story. Underneath the fabric of space, there is a sublayer, a basement level of reality where things are stitched together. Entangled particles are not two separate objects sending messages back and forth. They are a single object that just happens to be in two places. Imagine a long red thread. Now imagine passing that thread through a piece of paper so that only the two ends poke through two holes. From the surface of the paper, it looks like two separate red dots, two independent things. But if you look underneath the paper, you see the thread connecting them. You see that they are one. Entanglement is the thread beneath the paper of the universe. This phenomenon is happening everywhere. It is not just a trick performed in a lab. It is the glue of the cosmos. Every time two atoms interact, every time they collide or bounce or share energy, they become entangled. They leave a little piece of themselves with the other. They walk away carrying a ghostly memory of that meeting. Think of the air in your room. The molecules are constantly crashing into each other, billions of times a second. With every crash, they are knitting an invisible web of entanglement. The air is not just a gas, it is a tapestry. The light from the lamp entangled with the walls, the heat from your skin entangled with the sheets. And consider the beginning. Go back in your mind. Back before the earth, before the sun, before the stars. Go back to the Big Bang. In that first unimaginable moment, everything that exists, every ounce of matter, every drop of energy was crushed together into a single tiny point. Everything touched, everything was one. Then the explosion, the expansion, the great scattering. The universe blew apart, flinging matter outward to form the galaxies, the nebulas, the planets. But if everything was entangled at the start, does that mean everything is still entangled now? Are the atoms in your right hand entangled with the atoms in a star burning in the Andromeda galaxy? Is the breath in your lungs entangled with the dust on the surface of Mars? Is the universe just one giant, shimmering, entangled thing, pretending to be many pieces? It is a thought that borders on the spiritual, yet it is grounded in the cold, hard math of quantum mechanics. It suggests that isolation is impossible. You cannot cut yourself off from the universe. You are woven into it. When you look up at the night sky, you are not looking at a foreign place. You are looking at a part of yourself that has drifted away. There is a gentleness to this idea. It means that no matter how lonely the night feels, you are tethered. You are connected to the ground beneath you, to the air around you, and to the cosmic history that made you. We are now learning to use this spooky connection. We are building the future with it. Scientists are creating quantum internets. Imagine sending a message that cannot be intercepted because it doesn't travel through the air. It travels through the entangled link. Imagine teleportation, not beaming a person like in the movies, but beaming information, taking the delicate quantum state of an atom here and instantly recreating it there, across the world, using the bridge of entanglement. We have already done this. We have teleported the state of a photon from the ground to a satellite in orbit. We have sent a quantum whisper into space, and the satellite heard it. We are learning to pluck the strings of the invisible web. But tonight, let us simply marvel at the web itself. Close your eyes and visualize the space around you. Usually, we see empty space as a void, a gap, a nothingness that separates things. Try to see it differently now. See the space as a connector. See the invisible lines of light stretching from every atom to every other atom. A billion silken threads crossing the room. Threads connecting you to the window. Threads connecting the window to the tree outside. Threads connecting the tree to the moon. The universe is not a collection of lonely islands. It is a single, vast organism. It is a nervous system of light and gravity. When one part shivers, the whole web trembles. Feel that connection. You don't have to do anything to maintain it. You don't have to send a signal. You don't have to call out. It is built into your atoms. It is your birthright as a child of the Big Bang. You are entangled with the stars. And just as particles have a property that links them, they also have a property that defines them, a property that acts like a tiny internal compass. It is a spinning motion that isn't really spinning, a dance that happens without moving. We call it spin. As we drift further along these invisible threads, let us turn our attention to the tiny dancers that make up the world and the pirouettes they perform in the dark. Chapter 5. The Silent Pirouette. We are traveling inward again. We have floated through the web of entanglement, tracing the invisible threads that hold the stars together. Now we follow one of those threads down, shrinking smaller and smaller until we are face to face with a single electron. It is floating in the void, and if we look closely, we sense a motion. It is not moving across space, it is moving within itself. There is a feeling of rotation, a sense of a twist, a silent, eternal pirouette. We call this spin. But the word is a whisper of a lie. When you hear spin, you imagine a child's top whirring on a floor. You imagine the Earth turning on its axis, bringing the sunrise. You imagine a physical ball of matter rotating in space. But the electron is not a ball. It is a point. It has no surface. It has no equator to spin around. If an electron were truly spinning like a top, its edges would have to move faster than the speed of light just to generate the magnetic field we measure, and that is forbidden. So, what is it doing? It is carrying a secret form of momentum. It is carrying a permanent, built-in arrow of direction. Imagine a compass. A compass doesn't need to spin around to point north. It just has a direction. It possesses an orientation. Every particle in your body, every proton in every atom carries this tiny, invisible compass needle. This discovery began with a beam of silver. In 1922, two physicists named Otto Stern and Walther Gerlach performed an experiment that looked like magic. Visualize a dark laboratory. In the center, a small oven heats a nugget of silver until it evaporates. A thin stream of silver atoms, a ghostly metallic steam, drifts out into the vacuum. The scientists sent this stream of silver through the jaws of a powerful magnet. In the classical world, the magnets inside the atoms should have been pointing in every random direction. Some up, some down, some tilted left, some tilted right. If that were true, the magnet would have smeared the silver beam into a messy, vertical blur on the detector screen. But that is not what happened. When the silver hit the screen, it didn't smear. It split. The beam divided into two crisp, clean lines. One group of atoms went up. The other group went down. Nothing went in the middle. It was as if the universe forced the atoms to choose. Are you spinning up or are you spinning down? There is no sideways in the quantum world. There is no diagonal. Spin is quantized. It is all or nothing. Imagine a ballerina spinning in the dark. In our world, she can spin at any speed. She can slow down, she can speed up. In the quantum world, she can only spin at one precise speed. And she can only spin clockwise or counterclockwise, up or down. And stranger still, she never stops. An electron cannot stop spinning. To stop spinning would be to stop existing. The spin is not something it does, it is what it is. This tiny, ceaseless motion is the source of all magnetism. Why does a magnet stick to your refrigerator? It is not magic. It is the collective dance of billions of electrons. In a piece of iron, the electrons align their spins. They agree to dance in the same direction. Their tiny, invisible arrows all point the same way, and their microscopic magnetic fields add up layer by layer until they create a force strong enough to hold a photo against gravity. When you hold a magnet in your hand, you are holding a macroscopic quantum object. You are feeling the combined weight of a trillion quantum spins. But spin has an even stranger quality, a quality that bends the geometry of the world. If you take a rock and turn it around 360 degrees, a full circle, it returns to where it started. It looks the same. But if you take an electron and turn it 360 degrees, it does not return to its original state. It comes back changed. It comes back with a mathematical minus sign. It is facing the opposite way in the logic of the universe. To get the electron back to normal, you have to turn it another 360 degrees. It takes a rotation of 720 degrees, 2 full circles, to bring a particle of matter back to its beginning. It creates a double cover of reality. It means the electron sees a larger world than we do. It tracks a path that winds twice around the axis of existence. Drift with this image. Imagine walking down a spiral staircase. You walk a full circle, 360 degrees, you are facing the same direction, but you are on a different floor. You are not back where you started. You have to walk another full circle to find your original place. Matter follows this spiral logic. This intrinsic twist helps us categorize the entire universe. Everything you see is divided into two great families, based entirely on their spin. There are the fermions, the particles of matter. They have half-integer spin, 1/2. They are the dancers who need 2 turns to reset. And there are the bosons, the particles of force. They have integer spin, 0, 1, 2. They are simpler. They look the same after 1 turn. These numbers sound dry, but they define the texture of reality. Spin is what makes matter solid. Spin is what makes light flow. Spin is the reason you cannot walk through a wall. And we can listen to this spin. In hospitals around the world, there are giant white machines, MRI scanners, that are essentially giant ears listening to the spin of the atoms in your body. Your body is mostly water. Water is full of hydrogen, and hydrogen nuclei are tiny spinning magnets. When you lie in the scanner, a strong magnetic field lines up all those tiny spins, like soldiers standing at attention. Then, a pulse of radio waves knocks them over. As they spiral back up to their standing position, they sing. They emit a tiny radio signal. The machine hears this song. It maps where the water is. It draws a picture of your brain, your heart, your knees, based entirely on the rhythm of quantum spin. So, as you lie in bed now, feel the quiet rhythm of your own body. You are a galaxy of tiny spinning tops, billions upon billions of protons and electrons twirling in the dark, never stopping, never slowing down. They are generating a faint magnetic field that surrounds you like a cloak. You are magnetic. You are rhythmic. You are built of motion. The bed you sleep on is solid because of spin. The gravity that holds you is a conversation with spin. The light of the morning will be a wave of spin. Let yourself become a part of that rotation, not a dizzying spin, but a slow, cosmic turning, like the rotation of the Earth. Steady, reliable, ancient. The universe is not static. It is a grand, silent clockwork of aligned arrows pointing the way toward sleep. Chapter 6: The Stones and the Light. We have watched the dancers spin. Now we must look at how they dance together. In the great ballroom of the universe, there are 2 kinds of personalities, 2 distinct ways of being. There are the fermions, and there are the bosons. Think of them as the stones and the light. They behave differently. They follow different rules. And the difference between them is what makes the world interesting. It is what makes the world possible. Let us start with the fermions. These are the electrons, the protons, the neutrons. These are the particles that make up stuff. They make up the atoms of your body, the wood of the chair, the rock of the mountain. And they have a very specific personality trait. They are the ultimate introverts. They are the loners of the quantum world. There is a rule they must follow, a law written by a physicist named Wolfgang Pauli. It is called the Pauli exclusion principle. It sounds strict, doesn't it? Exclusion. The rule is simple. No 2 fermions can occupy the same state at the same time. They cannot be in the same place, doing the same thing, with the same spin. They need their space. Imagine a theater. The fermions are the audience, and the rule of the theater is that only one person can sit in each seat. If an electron takes the front row, seat A, no other electron can sit there. The next electron must take seat B, then seat C. When the front row is full, the next electrons must go to the second row, then the third. They stack up. They build outward. This simple refusal to share a seat is the reason matter has volume. Why is an atom big? Why isn't it just a tiny speck? Because the electrons refuse to crash into the lowest energy level together. They stack up in layers, creating shells. They puff the atom out like layers of an onion. This is why you can touch things. Press your hand against the mattress. You feel resistance. You feel a surface. That feeling is the Pauli exclusion principle in action. The electrons in your hand and the electrons in the mattress are fermions. They are governed by the law of no trespassing. They refuse to occupy the same space, so they push back. That pressure, that degeneracy pressure, is what you interpret as solidity. It is the force of quantum stubbornness. If fermions were allowed to share space, you would fall right through the bed. The bed would collapse into a speck of dust. The Earth would shrink to the size of a city. The entire structure of the world, the architecture of everything solid, is built on the politeness of fermions. You sit there, so I will sit here. But then there are the bosons. These are the particles of force. The photon, light, the gluon, the graviton. Bosons are the opposite of fermions. They are the extroverts. They are the joiners. They do not obey the exclusion principle. They love to share. Imagine the theater again. But this time, the audience is made of bosons, made of light. One photon sits in the front row, seat A. The next photon comes in. It doesn't look for an empty seat. It sits right on top of the first one. The third photon sits on top of the second. A million, a billion, a trillion photons can all occupy the exact same seat at the exact same time in perfect harmony. When they do this, they do not stack up. They merge. They amplify each other. They become a single giant wave. This is how a laser works. A laser is a choir of bosons singing the exact same note at the exact same time in the exact same place. It is a beam of perfectly coordinated light cutting through the darkness because the particles are willing to be one. Drift between these two feelings, the feeling of the stone, fermion, the feeling of being solid, of having boundaries, of saying, I am here and you are there. This is your body. This is the ground. This is safety. And the feeling of the light, the feeling of merging, of flow, of passing through, of saying, we are one. This is the heat of the sun. This is the Wi-Fi signal in the air. This is the force that holds the atoms together. The universe is a dance between these two tribes. The fermions build the stage. They create the walls, the actors, the props. They create the separation that allows individual things to exist. The bosons weave the story. They carry the messages between the actors. They fly back and forth, carrying electromagnetism, carrying gravity, carrying the strong force that binds the nucleus. Without fermions, there would be no structure, just a soup of light. Without bosons, there would be no interaction. The universe would be a dark, silent collection of dust that never touched, never saw, never felt. But together, they make a symphony. Think of a white dwarf star, a dying sun. It is collapsing under gravity. It wants to shrink to nothing. But the electrons inside it, the fermions, shout no. They refuse to be squeezed into the same state. They push back with their exclusion pressure. They hold up the weight of a star just by refusing to share their seats. A star is saved by the stubbornness of its parts. And think of a superconductor, a wire with zero resistance. In the bitter cold, the electrons, which are normally fermions, do something clever. They pair up, 2 by 2. And when they pair up, they pretend to be bosons. They lose their individuality. They join the choir. They flow through the wire without bumping into anything. A perfect, frictionless stream of current. Matter acting like light. Stones acting like water. The lines blur in the cold and the dark. But for now, resting in the warmth, appreciate the difference. Feel the solidity of the fermions supporting your back. Feel the warmth of the bosons, the infrared light, radiating from your skin. You are a vessel of both. You are structure, and you are flow. You are a boundary, and you are a bridge. As we move deeper into the night, we will see what happens when we strip away the matter and look at what remains. We will look at the spaces between the fermions, the empty air, the vacuum, and we will find that it is not empty at all. We are about to enter the fields. Chapter 7: The Ocean of Everywhere. We are floating now. Let the idea of solid ground fade completely. In the previous chapters, we talked about particles, electrons, photons, quarks, as if they were tiny objects, as if they were minuscule specks of dust or drops of light. But that is not the whole truth. That is only how they appear when they break the surface. Beneath the surface, there are no particles. There are only fields. Imagine you are submerged in a vast, endless ocean. The water stretches out in every direction, up, down, left, right, past the horizon, past the stars. The water is calm. It is still. But every now and then, a little ripple forms. A crest of water rises up, travels for a while, and then settles back down. If you were looking at the ocean from far away, you might point at that ripple and say, "Look, there is a thing. There is an object moving across the water." But you know the truth. The ripple is not a separate object. You cannot take the ripple out of the ocean and put it in your pocket. The ripple is the ocean, just behaving differently for a moment. This is the deepest secret of modern physics. The universe is filled with these invisible oceans. We call them quantum fields. They are everywhere. Right now, in the room where you sleep, the air is filled with them. They pass through the walls, through the bed, through your body. There is an electron field. It is a fluid that fills the entire universe. Every single electron in your body, the trillions of them spinning in your cells, is just a tiny ripple in that one vast field. They are not separate things. They are just local vibrations of the same universal sheet. When an electron moves from your hand to the sheet, it is just a ripple transferring from one part of the ocean to another. There is a photon field, the electromagnetic field. Every beam of light, every radio wave, every color you see is a wave in that field. There is a quark field, a gluon field, a Higgs field. The universe is a layer cake of these fields, all overlapping, all occupying the same space, ghosting through one another. This is a beautiful thought. It means that connection is the default state of reality. We often feel isolated. We feel like separate entities, cut off from the world by the boundary of our skin. But in the language of fields, separation is an illusion. You are made of the same stuff as the stars, not just metaphorically, literally. The ripple that is you and the ripple that is the sun are made of the exact water. Think of a guitar string. The string runs the length of the instrument. It is one object, but you can pluck it in many places. You can make a low note vibrate at one end and a high note vibrate at the other. The notes sound different. They are in different places, but they are excitations of the same string. Particles are the notes. The universe is the instrument. This explains why every electron is exactly the same. Have you ever wondered why every electron in the universe has the exact same charge, the exact same mass, the exact same spin? Why aren't there fat electrons and thin electrons? Why aren't there slightly faster or slower ones? It is because they are all cast from the same mold. They are all identical ripples in the same field. There is only one electron field. We are all just sharing it. Rest in this feeling of unity. The emptiness of space is not empty. It is a fullness. It is a presence. It is a thick, rich medium that connects everything to everything else. You are not floating in a void. You are floating in a substance. You are held by the fabric of reality. And these fields are not silent. They talk to each other. When an electron ripple moves through the electron field, it disturbs the photon field nearby. It creates a splash. That splash is what we call light. When you rub your hands together to warm them, you are creating a disturbance in the fields, transferring energy from the motion of your skin into the warmth of the air. You are a conductor of the cosmic orchestra. So let your breathing align with this idea. Inhale and imagine drawing energy from the vast field around you. Exhale and imagine your breath rippling out, changing the field forever. You are continuous with the cosmos. There is no edge where you end and the universe begins. Chapter 8: The Humming Void. We are sinking deeper into the ocean now. We have realized that the universe is made of fields. But what happens when the ocean is calm? What happens in the deepest, darkest vacuum of space where there are no stars, no atoms, no light? Is it truly quiet? Is it truly empty? The answer, whispered by the mathematics of the quantum, is no. Nothing is never truly nothing. Remember the uncertainty principle? The rule that says we cannot know the energy and the time of a system with perfect precision? Because of this rule, a field can never sit perfectly still. If a field were perfectly flat, zero energy, zero motion, we would know its state too precisely. Nature forbids this. So the field must jitter. It must tremble. Even in the absolute zero of the void, the fields are bubbling. Imagine a pot of water just before it boils. The surface is not yet churning, but it is not still. It is shivering. Tiny bubbles form at the bottom and vanish before they can rise. The vacuum of space is like that. It is a seething froth of virtual particles. These are ghost particles. They borrow energy from the bank of the universe, exist for a fraction of a nanosecond, and then pay the energy back and vanish. Matter and antimatter popping into existence, snap, and annihilating each other, crackle, in the blink of an eye. Every cubic centimeter of empty space in your room is alive with this activity. It is a cosmic hum, a background static of creation and destruction. We call this zero-point energy. It is the minimum amount of energy the universe can have. It is the floor, but the floor is vibrating. It sounds like a fantasy, doesn't it? Something scientists invented to make the math work. But we can prove it is real. We can feel the push of the ghosts. There is an experiment called the Casimir effect. Imagine taking two metal plates, perfectly flat, perfectly polished. You place them in a vacuum, very, very close together, thinner than a sheet of paper. There is nothing between them. No air, no light, nothing. They should hang there, still and silent. But they don't. They move. They are pushed together. Why? Because the nothing outside the plates is stronger than the nothing inside the plates. Outside, the ocean of virtual particles is wild and stormy. There are waves of all sizes crashing against the metal. Inside, the narrow gap, the big waves don't fit. Only the tiny ripples can exist there. The ocean is calmer. So the pressure from the outside storm pushes the plates together. The vacuum itself, the empty space, has a physical force. It has a weight. This is the heartbeat of the void. It is a comforting thought for the night. It means that silence is not an absence. Silence is a presence. When you close your eyes and the world goes dark, you are not alone. You are surrounded by a living stillness. The air is humming a lullaby of energy that has been playing since the beginning of time. It explains why black holes aren't truly black. Stephen Hawking realized that this bubbling vacuum interacts with the edge of a black hole. Occasionally, a pair of ghost particles pops up right on the cliff edge. One falls in, the other escapes. To us, it looks like the black hole is glowing. It is radiating heat. The vacuum is stealing energy from the monster bit by bit until the black hole evaporates into the night. So wrap yourself in the blanket of the humming void. It is not cold, it is vibrant. It is the soil from which everything grows. Before the Big Bang, there was likely just this, a fluctuating field, trembling in the dark. And from a random spark in that trembling, the entire universe unfolded. You are a child of the vacuum's restlessness. Chapter 9. The Ghost in the Wall. We have floated in the ocean. We have listened to the hum. Now we are going to try something impossible. We are going to walk through a wall. In the world of the day, barriers are absolute. If you throw a tennis ball at a brick wall, it bounces back. Every time. If you roll a marble up a hill and it doesn't have enough speed to reach the top, it rolls back down. Physics is strict. If you don't have the energy to overcome an obstacle, you stop. But in the quantum dream, obstacles are suggestions. Barriers are misty. This is the phenomenon of quantum tunneling. Remember that you are not a solid object. You are a wave. Imagine a wave crashing against a breakwater. Most of the water bounces back, but some of the water seeps through the cracks. Some of the wave extends to the other side. Particles behave the same way. When an electron approaches a barrier, an energy wall that it shouldn't be able to cross, it doesn't just hit it and stop. Its wave function, that cloud of probability, smacks into the wall. Most of the cloud bounces back, but a tiny, ghostly tail of the cloud leaks through the barrier. It extends to the other side. And because the electron is a wave of probability, if there is a piece of the wave on the other side, there is a chance, a small, real chance, that the electron will suddenly find itself there. It doesn't climb over the wall, it doesn't dig under it, it doesn't break a hole. It simply vanishes from one side and appears on the other. It slips through the fabric of reality like a ghost passing through a closed door. It sounds rare, a magic trick, but it is happening constantly. In fact, you owe your life to it. Look at the sun, or imagine it burning in the sky. How does the sun shine? It shines by smashing hydrogen atoms together to make helium, fusion. But protons are positively charged. They hate each other. They repel. To fuse, they have to get incredibly close. But the sun, believe it or not, is not hot enough to push them that close. According to classical physics, the protons should bounce off each other. The sun should not ignite. It should be a cold, dark ball of gas. So why is it burning? Tunneling. As the protons rush toward each other, they hit the wall of repulsion. They don't have enough energy to cross it. But every now and then, once in a trillion collisions, a proton decides to cheat. It borrows the magic of the quantum. It tunnels through the repulsion barrier and lands right inside the other proton. Snap! Fusion happens. Light is born. Every ray of sunlight that has ever warmed your face, every photon that feeds the plants that feed you, is a result of a quantum particle walking through a wall. The sun is a giant quantum tunneling machine. The daylight is a ghost story. We use this magic here on Earth, too. We have built microscopes, scanning tunneling microscopes that use a tiny metal tip, sharp as a single atom. We hover the tip just above a surface. We don't touch it, but we bring it close enough that electrons can tunnel across the gap. They jump from the surface to the tip, creating a tiny current. By measuring this current, we can feel the shape of individual atoms. We can map the bumps and valleys of the molecular world, reading the braille of the universe. And think of the enzymes in your body. Right now, in your cells, chemical reactions are happening that keep you alive. Some scientists believe that protons are tunneling their way through molecules to make these reactions faster. Your biology is using quantum shortcuts. So, as you lie in bed surrounded by walls, think of the freedom of the tunnel. Think of how the universe is not a series of closed doors. It is permeable. When the odds are low, when the barrier seems too high, nature has a way of slipping through. It doesn't force its way, it doesn't fight, it waits. It spreads out its possibilities, and it simply arrives on the other side. There is a lesson in this for the weary mind. Sometimes we face barriers in life, problems that seem too big, mountains we cannot climb. The quantum way is not to crash against them. The quantum way is to relax, to spread out your awareness, to realize that a part of you is already on the other side, to trust that, in time, you will find yourself there. We are almost at the end of our structural journey. We have seen the particles, the waves, the fields, and the ghosts. But there is one final state we must explore. A state of cold, a state of perfection, a state where the chaos of the universe finally stops and everything moves as one. Chapter 10. The Symphony of Cold. We are traveling to the coldest place in the universe, colder than the dark side of the moon, colder than the empty voids between the galaxies. We are traveling to a laboratory on Earth where scientists have learned to slow time down by freezing it. In our everyday world, heat is noise. Heat is the jiggling of atoms. The hotter something is, the faster its particles vibrate, bounce, and collide. It is a chaotic dance, a crowded room full of people bumping into one another. But as we lower the temperature, the dance slows. The noise fades. The atoms begin to calm down. We drop past the freezing point of water, past the freezing point of air, down, down toward the absolute floor of existence, absolute zero. At this temperature, the motion of the world almost stops. And when things get this quiet, the quantum spirits come out to play. We witnessed earlier how bosons, the particles of light, love to occupy the same state. But atoms are usually individualists. They keep their distance. However, if you cool certain atoms down enough, to a billionth of a degree above absolute zero, something miraculous happens. They lose their identity. They stop being this atom and that atom. Their wave functions, those clouds of probability, begin to expand. They grow larger and larger as they slow down. Eventually, the clouds overlap. They merge. Suddenly, a million separate atoms snap into a single state. They become one giant, shimmering superatom. We call this a Bose-Einstein condensate. Imagine a choir. Before the conductor arrives, everyone is talking, coughing, tuning their instruments. It is a mess of sound. That is a normal gas. Then the conductor raises a baton. Silence falls. And then everyone sings the exact same note at the exact same pitch at the exact moment. The sound is pure. It is perfect. It is one voice coming from 100 throats. That is the condensate. It is a state of matter where the quantum world becomes big enough to see. If you looked at a droplet of this condensate, you wouldn't see a speck of dust. You would see a single quantum wave, rippling and interfering with itself. And this leads to one of the most magical substances in existence, superfluid. Imagine a cup of coffee. If you stir it, it swirls. Eventually, friction against the cup slows it down and it stops. Now, imagine a cup of superfluid helium. You stir it, it swirls, and it never stops, ever. A billion years could pass, and that vortex would still be spinning exactly as fast as the day you started it. Because in this state, friction has vanished. The atoms are moving in such perfect unison that they don't rub against each other. They flow like ghosts passing through a wall. It gets stranger. If you leave a cup of superfluid sitting on a table, the liquid will not stay in the cup. It will climb the walls. A thin film of atoms, driven by quantum curiosity, will creep up the side of the glass, go over the rim, and drip down the outside until the cup is empty. It is a liquid that defies gravity. It is a liquid that flows uphill. This is what happens when the chaos of the world is stripped away. We tend to think of nature as messy, but deep down, nature craves order. The superfluid is the universe's dream of perfection, a flow without effort, a motion without loss. As you lie here, stillness settling over you, imagine your own thoughts becoming like that superfluid. The friction of the day is gone. The resistance is gone. Your thoughts are no longer bouncing around like hot atoms. They are cooling. They are merging. They are becoming a single, smooth stream, flowing effortlessly toward the ocean of sleep. You are climbing out of the container of the waking world, spilling gently over the edge into the dark. Chapter 11. The Forever Flow. We remain in the cold, but now we turn our gaze to a wire, a simple thread of metal. In the waking world, sending electricity through a wire is a struggle. Electrons try to move, but they crash into the atoms of the metal. They get scattered. They generate heat. This is called resistance. It is the tax we pay for energy. Every time you turn on a lamp, some energy is lost to the heat of the struggle. But in the deep quantum cold, a truce is called. In certain materials, when the temperature drops, the electrons, those lonely, antisocial fermions, do something unexpected. They find partners. They form pairs, called Cooper pairs. It is a delicate romance. They are not touching. They are often thousands of atoms apart, but they are linked. They move together, and when they pair up, they stop acting like fermions. They start acting like bosons. They join the choir. Suddenly, the resistance vanishes. The electrons stop crashing into the metal. They glide through the lattice like a phantom train floating above the tracks. This is superconductivity. Imagine a ring of this wire. If you start a current flowing in it, that current will flow forever. You could unplug the battery, walk away, come back in 1,000 years, and the electricity would still be circling undiminished. It is a perpetual motion machine, permitted by the laws of quantum mechanics. This is the forever flow. It is the closest thing to eternity we can build. And this state has a shield. A superconductor does not just carry electricity perfectly, it rejects magnetism. If you place a magnet above a superconductor, it will not touch the surface. It will hover. It will levitate in mid-air, locked in place by invisible quantum hands. This is called the Meissner effect. It is a quiet insistence on purity. The superconductor says, I am a perfect state, and I will not allow the magnetic field to disturb me. We use this magic today. Inside the giant MRI machines in hospitals, there are coils of superconducting wire, bathed in liquid helium, carrying massive currents without a whisper of heat. They create the magnetic fields that see inside your body, the image of your brain, your heart, your bones. It is made possible by the forever flow. There is a peace in this concept. We spend so much of our lives fighting resistance, fighting traffic, fighting deadlines, fighting our own worries. But nature shows us that there is a state where the struggle ends. There is a path of moving that requires no force. There is a path where the energy you give is never lost. Let yourself find that path now. Imagine the nerves in your body relaxing. The signals from your brain to your muscles are slowing down, smoothing out. There is no resistance in your body, no tension in your shoulders. You are a superconductor of calm. The peace flows through you, looping round and round, protecting you from the noise of the outside world. You are hovering, levitating in the safe, cold silence of the quantum night. Chapter 12. The Quantum Morning. We have been far. We have been down to the grain of the universe. We have spun with the electrons. We have floated in the fields. We have frozen in the deep cold. But now the journey circles back. We must rise from the basement. We must drift back up, layer by layer, toward the surface. As we ascend, the atoms begin to wake up. The superfluids evaporate into gas. The Bose-Einstein condensates break apart into individuals again. The superconductors warm up, and the resistance returns. The ghosts of tunneling settle back into solid walls. The fog of uncertainty sharpens into the furniture of your room. You are back, but you are different, because now you know what lies beneath. When you wake up tomorrow and the sunlight hits your face, you will know that it is not just warmth. It is a rain of photons, born from quantum tunneling in the heart of the sun, flying as waves across the void and collapsing into particles the moment they touch your skin. When you pick up your phone to check the time, you will know it is not just a machine. It is a sculpture of quantum mechanics. The transistors inside are guiding electrons through quantum tunnels. The GPS is listening to atomic clocks that tick to the rhythm of energy steps. The screen is glowing with the quantized light of LEDs. You are holding the strangeness of the universe in your hand. When you look in the mirror, you will see a being made of stardust and fields. You will know that the atoms of your body are vast cathedrals of empty space, held strong by the exclusion of fermions. You will know that you are entangled with the air you breathe and the ground you walk on. You will know that deep down, in the quiet hum of yourselves, you are vibrating with the same energy that birthed the stars. The world of the day looks solid, it looks separate, it looks simple, but you know the secret. You know that underneath the mask of the classical world, the dream continues. The particles are still spinning, the waves are still flowing, the web is still connected. The magic didn't go away just because you woke up. It is weaving the reality of your life, moment by moment. So, sleep well, traveler. You do not need to understand the math. You do not need to solve the equations. You are the equation. You are the solution. You are the wave that has decided for a brief, beautiful moment to be a person. Drift now. The fields are holding you. The spin is rocking you. The vacuum is humming its lullaby. And the universe is watching over you, entangled and whole. Good night.